I am DJ Ware. On this episode of the Cyber Gizmo, yep, we're back to ZFS again. And what we're going to do today is I'm going to go through what I did for tuning. And then I'll just talk about I'm not going to go too deep into this. It's just the way I do my performance tuning is I start with the workload that I want to use, which is typically, in this case, is 1080p video files and 4K video files. That's what I want to use for this test, because that's the production workload that this is going to do. So I'm not going to test the network access yet, even though I have already tested it. I know that it works, but I'll do that in a future video. But right now I want to go through the performance tuning results to show you what happened and how things change. So why don't we get started and take a look at those tests. Okay, so let's take a look at the results here. I'm just going to say this. They're the same except for the device names. That's the only difference between them. And just quickly, I used A-shift 12. Case sensitivity is insensitive. That's more of a convenience for me than it is a performance factor. A time is equal to off. Normalization is equal to form D. That's the default on FreeBSD. It is not the default for Linux, however. So if you ever want to be able to mount the Linux pool on FreeBSD or vice versa, you want to make sure that the normalization is the same. You'll also want to align any other variables that you use that are global. That is, they're set by the pool and not by the data set. So compression, I set here to LZ4 just so I'll remember to do it. Why not one of the others? I'm going to probably get some feedback on that, but that's okay. LZ4 is the new kid on the block. That's the latest compression algorithm. It is the most efficient. It is the fastest. It does come with a higher CPU cost, though, so you may not want to do that if you're on a slower CPU. But these are very fast, and yeah, I'm going to use LZ4. It's just better overall for compression. Now, record size is 1 meg because these are video files. Yours may differ. If you're working more with small files, you may want to make yours 128K. As far as the pool, it is a mirror on both sides, and that's merely because that's the only number of drives. I only have 2 drives on Proxmox at present that I can use, so I can't go to a Z-RAID. Production is a Z-RAID, so I did not. I'll probably do a separate performance tune for that just to see which one of these is better. But anyway, between Ubuntu and FreeBSD. My system memory in both VMs is 16 gig. So in Ubuntu, you set argmax to however much memory you want to hand over to the arc, which is that's basically your cache. So 8 gig is what I chose, took half of it. Now you can go higher. You can go lower. It just depends on how much memory you want to give up. So it won't go above this. That's the fence for the cache size. On FreeBSD, you set it differently. It's a syscontrol, and you do vfs.zfs.arc_max. And you'll probably, unless you're putting this into the boot config, or it's boot/loader.conf, you'll probably want to go long form with the 8 gig because syscontrol doesn't seem to like the 8 gig very much. The 8G doesn't seem to like that, so you might have to lengthen it out so make it the actual number of bytes. As far as the properties, these are both the same. Record size again is 1 meg, and compression. I'm just showing this again. A time is off. Sync is standard. I did test both with it disabled and with standard. Primary cache I set to all for both the primary and secondary. I did experiment with just doing metadata. It didn't really seem to affect it all that much. Now, log bias is throughput. Redundant metadata is equal to all. I did play around with this being most and all, and yeah, there was some minor differences in the performance. So you might want to experiment with that, doing redundant metadata if you're working with similar workloads to mine. ACL type is NFS v4 on BSD. That matters. On Linux, it does not matter because it isn't implemented. Rel time I have set to on. That has to do with how many times it actually tries to write to disk. The other thing is I did create a slog on both systems, and I did create a cache on both systems. Again, just like last time, the write, this is the initial write for a new sequential file. And then we have a sequential read on that file, and then we have a reread, which goes and basically it repeatedly goes back and rereads the file over and over again. So what did we get here? I fixed the title, so it's FreeBSD 14.2, Linux Ubuntu 24.10, and this is server versions of both of these. There is no GUI installed on either one. So initial write on FreeBSD versus Linux. Linux is slower, no question about it, and FreeBSD won this race. FreeBSD on the reread, it's in the noise here. I would say that with the exception of the lower, like the worker 1 and worker 2, that was kind of in the first worker, Linux did better with the reread, and the second worker, FreeBSD did. But then when you get out to the 3, 4, and 5 simultaneous users, they're close. Linux is a little faster in the final one, but it's a little bit faster in 4 and 3. But, I would say that's noise. I wouldn't say that's close enough to really be, say, definitively Linux is faster or FreeBSD is faster here. They're pretty close. Well, once you get them tuned up the same, they should run pretty close the same, unless your device is doing something weird. As far as the read is concerned, Linux does well. Again, same kind of thing in the worker 1, but then in worker 2, that's a dead heat there. That's pretty close. And then you have the worker 3, which is a little slower for FreeBSD and a little bit faster for Linux. Again, it's very close on 4. That's a dead heat. I would say Linux is slower in the final one compared to FreeBSD. FreeBSD just barely edges it out. So you're starting to see kind of what they were talking about, the FreeBSD people were talking about, and when they said it's faster than Linux. But let's keep going. So the FRead test, and this is the normal FRead call, which is a buffered stream read. And it also uses blocks. So it wants to write blocks of data, and it's meant to stream to the disk just as quickly as it can. So this is reading a stream of data from the disk. And then the write is the other way around, where it's streaming data coming from memory going to disk. And again, it is blocked, so you can write as large a block or as small a block as you want. I ran into a problem last time with FWrite, and you saw that on the last benchmark, where FreeBSD was just like it was just an order of magnitude slower, right across the board, than Linux. And so what was going on here? I dug into it. I wrote a program that does the FWrite call directly, doing buffered reads, compared it against Linux and against FreeBSD. They're both neck and neck, no difference, which is what I would kind of expect, except unless there's some optimizations between. FreeBSD uses libc for its library. Linux uses glibc, which is it has been modified. Both of them been modified a lot over the years. Yeah, it's possible that glibc might have some optimizations that FreeBSD doesn't have, and vice versa as well. There may be some optimizations in FreeBSD that Linux doesn't have. But the long and the short of it is I can't find any issue with ZFS writing using FWrite as long as I don't use IO Zone 3. The minute I call in IO Zone 3, it's doing something weird. I traced it, and it's issuing a slew of small blocks followed by a bunch of large blocks, and then it's going back to small blocks, and it's kind of all over the map in the way it's testing it. It's like it's smashing it with a lot of data, then it's hitting it with a whole flurry of small block writes, and then it's coming back. So there's something that's getting tripped up here, and to me, it doesn't appear to be anything that ZFS is doing. It looks like it's lower level into maybe the interactions between IO Zone 3 and libc. There's something going on that is just sending FreeBSD over the wall, right? So I didn't investigate it further. So I opted instead to just eliminate this test altogether from the geomean. So we'll look at the data, but I'm not going to use it because there's obviously something wrong with IOZone and libc. The problem does not occur under glibc on Linux. As you can see, though, Linux does have an advantage in the early game, but it quickly loses. It falls behind FreeBSD on the fread. Now, the FWrite, we already know, that's what we were just talking about. You can see clearly there's an issue here that FreeBSD is not recording enough writes. So we have mixed workload. This is mixed reading and writing in random locations within the file. So, this has more impact on rotational media than it does SSDs. So, P-reads are more typical of C programs. This is the just the normal read and a normal write. These typically allow you to jump to a specific part of the file and begin reading, so you can specify an offset or not to be able to do that. Okay, so in the mixed workload, FreeBSD starts out again slower, but then passes Linux up and stays faster all throughout the run. On the P-read, it's the same thing. FreeBSD kind of ramps up a little bit slower, but then that is a dead heat, except for item 4. Yeah, except for the worker 4, Linux is slightly faster here. So is that another clear winner for Linux? No. So the FWrite on FreeBSD and Linux, again, this time Linux starts out slow and FreeBSD starts out faster. And then Linux just doesn't quite catch up. So that's a clear win for FreeBSD there. Random reads. Now this, for my workload, random reads and random writes are not important to me just because of the nature of the type of I/O I'm doing, but they might be important to you if you're doing databases, or you're doing index sequential, or you have random files that you are using in your system other than databases. Random writes, the performance of writing a file with access is made to random locations within the file. So, all right, we know what those are. So how well did we do here? So FreeBSD starts out slow again, but then picks up speed toward the higher end, and then they kind of even out. I would say Linux starts out fast, and then hits the second worker, and then kind of goes slower. It picks up speed again in the third, and then they're in a dead heat in the fourth, and then both of them are dropping back. Linux drops back a little further than FreeBSD. They're close. I would say, with the exception of the first two runs, the worker 1 and 2, there isn't really a clear differentiator between those two. On the right, Linux starts out slower and stays slower. So there's a clear win for FreeBSD there. Yeah, but now we have rewrite tests. That's rewriting a file that already exists. It's probably updating metadata or something other in the file periodically to refresh it. And then reverse reads, again, we've talked about this. These are compilers doing backwards. Strided would be when you had things like imagery that had metadata in the front and it's reading the metadata to determine the file length, or maybe the codec that's used to compress it, and then, and then it's using then it offsets to the beginning of the image or the beginning of the video even to begin reading and processing that. FreeBSD a little slower in the initial worker 1. Worker 2, it blows way past Linux in the worker 2. Worker 3, Linux picks up. So you can see that they're clearly trading blows here. And again, by the time you get to the end, no clear winner, right? So yeah, that's noise on the 5th worker. So you can't hand it to either one, I don't think, because it's back and forth, and then finally they end up in a tie. The rewrite FreeBSD and rewrite Linux, I would say Linux again starts out slow and then picks up a little bit of speed but doesn't regain it all, and FreeBSD walks away with the rewrite. Strided reads, Linux picks up speed initially on worker 1 but then falls behind in 2. It picks up, this is the same pattern again. So obviously there's some differences in the algorithms for how these two are maybe processing the ARC, or actually, processing the cache. There might be some differences in the way both of those are being handled. So again, they end up in a proverbial tie, with FreeBSD, I think, in the 5th having a slight edge over Linux. Geomean, photo finish to be able to figure this one out. So yeah, on the geomean, FreeBSD clearly starts out faster in the 1st worker. It is faster overall, even in the 2nd and in the 3rd and in the 4th, and then they're in a dead. Well, I would say I'd say it's an edge. It's close. FreeBSD is better for this particular workload overall. Is that enough to make me switch back to FreeBSD? Maybe. It might be. It might be. There are some advantages to going back to FreeBSD for my particular workload because it is video, and there are some benefits that FreeBSD has that aren't yet implemented in Linux. So that could be reason enough to do it. But performance-wise, it is a close race. I mean, that's I would say too close to call. But I am going to say this. I think FreeBSD, once you get both of these tuned up, and there might be some additional tuning parameters. I didn't spend hours and hours on tuning it, but I basically went through until I got both of them up to just about the same peak. Now, when I finished my initial run, I did turn sync off. FreeBSD does pull ahead a little bit more if you do that, but I can't tell you to do. I won't recommend that you do that in production. I certainly wouldn't do it. Yeah, I mean, you're relying on. There is a TXG that handles when to do that. And if you're interested, we could probably cover that sometime down the road, but I don't think it's necessary to go that deep today. Yeah, so the baseline showed me that I needed to tune, right? And then I was able to use, the recap is, I ran FIO, reads and writes. Now, FIO will also handle random reads and random write workloads as well. So you can set it up any way you want. You can specify the block sizes. And by the way, the IO zone here that I'm running it's a 1 meg, the R value, that is the record size, is 1 meg. That matches up with the record size for ZFS. And then the file size I set to 5 gig. And the reason I did that is because my pool size are pretty small. They're only like 32 gig. So I didn't want to, and when you get to that fifth worker, you've got 5 gig files out there. So I didn't want to push it over the 80% capacity because at that point you start running into issues with performance on ZFS. So I haven't tested this on hardware yet. I'm planning on doing that on my production system with rotational drives. That's right here behind me. And we'll see how that is. I might just post a short note. I hope to see you again in the future and have a Merry Christmas. And if I don't see you in the New Year, Happy New Year.